In this video, we're going to solve this television viewing problem that uses a radical equation. So we have this formula, which models weekly television viewing time H in hours by annual income I in thousands of dollars. What annual income corresponds to 44.6 hours per week watching TV? So what we're going to do is we're going to plug in and solve. And looking at my equation, I can see that the H is the number of hours of weekly television viewing time. I is the annual income. And I want to find the annual income that corresponds to 44.6 hours watching TV. So 44.6 is what I'm going to plug in for H. And then once I plug that in, I'm going to be solving the equation for I. So 44.6 equals negative 2.3 times square root of I plus 67.6. Now, to solve this equation, what I'm going to do is I'm going to get the I by itself. And then specifically the square root of I need to get that by itself. So first I'm going to subtract away this 67.6 from both sides. And you might want to grab a calculator to do this real quick, but when you type that into your calculator, you should get negative 23. Equals negative 2.3 times square root of I. Now, we didn't see an example like this yet, but when I have this number in front of the square root, it's multiplied by square root of I would get rid of it by dividing both sides by that number. So I am going to divide both sides by negative 2.3 here. Just as if it were like negative 2.3x, I would divide to get rid of it. It's the same idea here. So divide both sides by negative 2.3, and when I divide that through, I get positive 10. Negative divided by negative is positive, and that equals the square root of I. So once I have the square root by itself, I can square both sides to get rid of the square root. And so I get I equals 100. Now, it's important with these problems to go back to your question and think about what that means about the answer. I'm looking for annual income in thousands of dollars. So this is not $100 annual income, it's $100,000 annual income. So that would be my answer to the question. Would be $100,000.